The first two videos in this trigonometry subtopic covered a brief history of how degrees, minutes and seconds came to be angular measurements and how we can use them on a calculator. The original Greek definitions of angles were based on a right angle being a quarter of a turn. Once a revolution was divided into 360 units called degrees, we could then redefine a right angle too. Equally, we can do this for many fractional amounts of 360 degrees, due to the many factors of 360, as seen here. The large number of factors found in 12, 60 and 360 undoubtedly influenced the decisions to maintain this non-decimal format for measuring angles and time. Remember, this was in the days long before calculators. 1/6 of 360 is 60 degrees. 1/3 is 120 degrees. Naturally, we can easily calculate any multiples of these as well. 2/3 will be 2 lots of 120 degrees. 3/4 of a revolution will be 3 lots of 90 degrees. That's 270 degrees. Looking at the factors in their matching pairs is far more useful. 6 lots of 60 is 360 degrees, so 1/6 of a revolution is 60 degrees, and in reverse, 1/60th is 6 degrees. Using 12 times 30 is also 360, we have 1/12 of a turn being 30 degrees, and 1/30th is 12 degrees. Pairing your factors like this is always useful in all areas of mathematics, especially when using mental calculation techniques. Even though the number 60 has fewer factors, there are still enough to make finding fractional degrees and minutes simple, if the denominator comes from this set of factors. And remember, you can apply these to time as well. Half a degree is quite obviously 30 minutes. Then a quarter must be half of this, being 15 minutes, so that 1/15th is 4 minutes. Many of these can also be derived from each other. For example, 1/5 is twice the size of 1/10, and 1/20th is half of it instead. Using the pairs of factors will not only allow you to find fractions of revolutions or degrees and minutes, but also to convert some angular measurements to and from degrees and minutes quite easily. This is also very useful for working with time, but conversions involving seconds won't be needed often with angular measurements in high school trigonometry, since most students will only be required to work with degrees and minutes. Of particular interest is 1/10 of a degree, which equals 6 minutes, since this helps us convert to and from decimal form. Each 6 minutes is 1/10 of a degree, which is 0.1 degrees. So 12 minutes is 0.2 degrees. 18 gives us 0.3, etc. Halving 0.1 gives us 0.05 degrees, which must be equivalent to 3 minutes, being half of the 6 minutes. So each 3 minutes is another multiple of 0.05 degrees. For 9 minutes, we can see that 9 is 3 lots of 3, so it's 3 lots of 0.05, giving us 0.15 degrees. Or 9 minutes can also be thought of as 6 plus 3 minutes, giving us 0.1 plus 0.05, and 0.15 is the answer as before. Let's try a couple of examples. First though, a quick reminder about the correct notation for degrees, minutes and seconds as seen on most calculators. Using this notation is much more efficient than writing the units in words. Pause the video if you'd like to try these examples on your own first. In example 1, we are changing from decimal form into degrees and minutes and seconds if required. For part A, the 0.7 degrees must be 7 lots of 6 minutes, which is 42 minutes. So we have 1 degree, 42 minutes. Part B, we have 7.03 degrees. This is more challenging because we need 3/100ths of 60 minutes, which is not on our list of easy factors. However, 1/100th is easily found by simply moving the decimal point 2 places left, giving us 0.6 minutes. 3 of these will be 1.8 minutes. Now we have 7 degrees, 1.8 minutes. But we can do better. 1 minute is 60 seconds. 0.1 minutes must be 1/10 of 60 seconds, which is 6 seconds. So 0.8 will be 8 times this, giving us 48 seconds. So without a calculator, we have easily changed 7.03 degrees into 7 degrees, 1 minute and 48 seconds. Even as the decimals become more difficult, this technique is still useful, particularly when you have access to a calculator without a degrees, minutes and seconds button. Although many of you could probably do this one mentally, I will demonstrate the process using these easier values. 0.03 times 60 gives us the 1.8 minutes. And then we calculate 0.8 times 60 seconds to get the 48 seconds. You can do this no matter how difficult the decimal value, such as this one. Pause and try it for yourself if you like. The calculator tells us that 0.508813 multiplied by 60 gives us 30.5278 minutes. Subtract the 30 and press equals, so now we can multiply the remaining decimal part by 60 again to find that we have 31.7268 seconds, which can be rounded to 32 seconds to the nearest second. The aim in this video is not only to help you develop these techniques, but also to help you better understand what the degrees, minutes, seconds button is actually doing when you use it. Back to our examples. In example 2, we are doing the opposite, changing from degrees, minutes and seconds into decimal form. Part A is easy if you recognize that 24 minutes is 4 lots of 6 minutes, so it's 4 lots of 0.1 degrees. We have 37 degrees, 24 minutes must be equal to 37.4 degrees. We could also have written 24 over 60 and simplified to 2/5 or to 4/10, which of course is 0.4. Part B is more challenging. If you are good with factors, you might recognize that 39 is 13 lots of 3 minutes. Each 3 minutes is 1/20th of a degree, or half of 1/10. Either way, we know it's 0.05 degrees. So 13 lots of 0.05 gives us 0.65. We have 12.65 degrees in decimal form. We could have used any combination of factors. 6/10 is 6 lots of 6 minutes, giving us 36 minutes. Then 3 minutes extra gives us the extra 0.05 for our total of 12.65 degrees. Alternatively, we could write it as a fraction, 39 over 60, which simplifies to 13 over 20, and again we have 13 lots of 0.05. There are lots of possibilities to effectively convert this example into decimal form without reaching for a calculator. But here's one that's not so easy. The 16 minutes is 4 lots of 4 minutes, which is 4 lots of 1/15th of a degree. Without a calculator, it's not easy to do mentally. A 15th is 1/3 of 1/5, so it's 1/3 of 0.2, or 0.3 recurring multiplied by 0.2. You might be able to see that it's 0.06 recurring, simply by doubling all the 3's and adding the extra decimal place required. But we still need 4 of these. It would obviously be quicker, easier, and more reliable to reach for a calculator. If you absolutely needed to do it without a calculator, then converting 16 over 60 to 4/15 and converting this to a decimal by dividing might be easier. 15 into 4 doesn't go, carry the 4. 15 into 40 goes twice with a remainder of 10. 15 into 100 is 6 with a remainder of 10 again, and quite quickly we find the repeating 6. With a calculator, it's trivial, even without a DMS button. Let's finish with a more challenging example. We want to change 25 degrees, 13 minutes, 43 seconds into decimal form, using a calculator that doesn't have a degrees, minutes, seconds button. 43 over 60 is 0.716 recurring minutes. Add the 13, we have 13.716 recurring minutes. 13.716 recurring divided by 60 gives us 0.22861 recurring degrees, or 25.2 degrees total, correct to one decimal place. Let's confirm this with the degrees, minutes, seconds button. Type 25, hit the DMS button, 13, DMS button, 43, DMS button, press equals, then hit the DMS button again to change into decimal form. And here we have our 25.22861 recurring degrees. Knowing how to change into and out of the base 60 format without using the DMS button on a calculator is good for your overall understanding and of course for your general non-calculator skills. I encourage you to use non-calculator techniques whenever you can, in all areas of your mathematics and your everyday life.